Jim Pyle, and I'm here on behalf of the sponsors of Professor Roald Hoffmann's visit to UniverCity 90 and to Ball State University. And I would like to acknowledge those people who have been instrumental in planning and supporting this visit. First of all, the Academy for Science, Mathematics, and Humanities, with whose students and faculty Dr. Hoffmann made a presentation last evening. The Society of Sigma Xi, which is our research honorary, which supports research in the sciences. The Science Day Committee of the College of Science and Humanities, which has had about 600 visiting high school students on campus today. The Department of Chemistry, at the Office of Research and Sponsored Programs, and most of all, the conveners of the UniverCity 90 event. Now, Professor Hoffmann is, I think, a fine choice for an event which stresses communications among the disciplines in a university, both because of his range of contributions and because of the importance of those. Dr. Hoffmann won the Nobel Prize in 1981, and in my view, in the view of many chemists, that contribution was a landmark contribution. His work with Professor R.B. Woodward identified a new concept, namely the conservation of orbital symmetry, by which chemical reactions needed to be assessed. And that changed the way in which chemists thought about the nature of reactions and chemical change. And any contribution which causes such a paradigm shift is in the landmark category. What does one do after the Nobel is an intriguing question in the world of science. And in the case of Professor Hoffmann, he's continued to contribute to a stream of further investigations. But at the same time, there has been a definite addition of some other interests. One of those can be illustrated by something that I observed while I was on the Cornell campus about a year ago for a chemical meeting. I have a tendency to try to take a look around the campus and see what it's like, and Cornell is a beautiful place to do that. And as it happened, as I was doing some exploring of that sort, along came a tour group led by a young man of the sort that we call the Cardinal Corps, who was talking to prospective students and faculty. And he said, you know, when you come to Cornell, you really have a chance to meet some really fine faculty. He said, even in something like chemistry. He said, I have to say that when I went to my freshman chemistry class, I was not expecting much, and who should walk in as my professor but a Nobel laureate? And indeed, I knew who that was because it's only one at Cornell. But it also reflects an interest in teaching and in chemical education, which led Hoffmann to some achievements in the arena of communicating via television and teaching via television. The result of that has been a series which has begun to be broadcast on PBS this fall called The World of Chemistry. We've used it here, and it's intended to focus the attention of young people upon the many important seminal ways in which chemistry can help us understand and deal with issues that are before us. Then there is Hoffmann, who is a philosopher and poet, who's recently had an article accepted in a journal on the philosophy of aesthetics. And tonight he's going to be participating in a poetry reading here as his final event on a busy schedule. He also is the only chemist I know who made reference in a recent publication to the work of Buckminster Fuller. And since I happen to admire Fuller, I thought I would end my introduction by reading a comment from Fuller's work, Synergistics, which I think describes Hoffmann and his topic today. The greatest and most enduring discoveries and inventions of humans on our planet are those of the scientist artists, the name joined, or artist or scientist. The name of artist or scientist, though often self-professed, can only be accredited to an individual by others who in retrospect discover the enduring quality of the symmetries with which the individual converted his conceptioning to the advantage of others, and realizations of increasing inter-advantage in respect to survival, the gradual discovery of the function in universe which humanity has been designed to fulfill. In many ways that describes our speaker, describes UniverCity 90, and it describes our topic, One Culture. Dr. Roald Hoffmann.
The subject of my talk, in fact, is, I think, fitting with the theme of the university, and that theme being uncommon ground. The title that I used, One Culture, of course, is meant to evoke something else, and that is an essay, a speech by C.P. Snow about the two cultures. In fact, it's just about 30 years ago since C.P. Snow spoke about the two cultures. He postulated a certain rift between scientists and technologists on one hand and humanists on the other. The world views of these groups clashed, shaped by their mutual ignorance, he said. The scientists did not study literature, the well springs of our civilization, and the humanists didn't know about the second law of thermodynamics or the integral calculus, equally great creations of the mind. The two cultures were ignorant and therefore intolerant of each other, unable to communicate intelligently. Now, C.P. Snow was very well qualified to speak of these two worlds. He started out as a scientist, a spectroscopist, physicist. In fact, to my surprise, I found myself citing a paper of his in a paper that I wrote just a dozen years ago. And he became a university administrator, a science administrator, especially during the Second World War. And he was a novelist, the author of an 11-volume series of novels, a meticulously crafted and psychologically perceptive, if somewhat turgid, study of English public and private life. Now, there was something about that split which he mentioned which struck a resonance. And if we look now today, 30 years later, about the two cultures, and we ask how some of his points hold up, then we see that some of them, in fact, are really still valid. The scientific illiteracy of the literati persists, exacerbated, if anything, in a world of rapidly accelerating technology, and scientists make very little efforts to tell their humanist or artist friends what it is that they are doing. They're supposed to be doing something exciting and creative, but they can't quite tell you what it is. They lapse too easily into paeans to technological achievement instead of trying to communicate what they are doing. The great support of science across the world and of technology has introduced a certain psychological divisiveness ensuing from the growing affluence of scientific research. I know that my colleagues in chemistry here or elsewhere complain about what they are getting, but if you compare rationally their lifestyle in terms of access to secretaries or machines or buildings and such, you will find that they are order of magnitude or more ahead of what people in the humanities have to put up. In a number of ways, Snow, though, was wrong. And let me first mention the trivial ways and then tell you in positive way why he was wrong. He overestimated the innate political liberalism of scientists. he reasoned that because scientists are open or are to new ideas, or supposed to be open to new ideas at the frontiers of their field, that in general they would be open to new ideas. And the wave of student troubles, for instance, in the late 60s, which polarized people around the world, or in a response to ecological concerns of today, scientists, if anything, consistently adopt conservative rather than liberal positions in the spectrum of responses. Snow's attribution of scientific and technological illiteracy to people in the humanities misjudged the prevalent extensive illiteracy within science about other sciences. A physicist's perception of a field as close to their own as chemistry border on the unreal. And there are very few of us who could do what a Connecticut Yankee in King Arthur's court could do, which is to reconstruct our technology from all those beautiful partial differential equations that we know. His characterization of humanists and artists as natural Luddites, and he was referring here to the movements at the beginning of the Industrial Revolution, where in quasi-religious movements people destroyed the technology or tried to do so as a protest against the bad side of the Industrial Revolution. His characterization of humanists as such, I think, has just proven incorrect. When I talk to my friends in the humanities and I talk about modern technology, all I hear from them is, we want as many Xerox machines as you have. And that's all. There is no opposition to that at all, to the technology. I think he also was wrong in a number of other ways. I think he misjudged he mistook academic life for the totality of our existence, and he focused on the trivialities that divide us. He called us two polar groups. And I think that may have been, in his setting, somewhat class conditioned by where he was at an elitist English university. But when I look at our local community and the attitudes of scientists and other people, let's say, toward important issues of education and others, I don't see any difference. I do not hear or feel any greater sensitivity among one or another group of colleagues with respect to the treatment of their spouses, parents, or children. Let me put it as provocatively as I can to both groups of people. If scientists are more rational human beings than other people, as they would like us to believe sometimes, boy, they've done an awfully good job of limiting their rationality to their working hours. And if people in the humanities have learned something about the important things in life, like how to deal with grief, with love, and things like that, then they seem to be singularly incapable of applying it to their own lives as well. I think there is just one group of people. The problems that face us outside of our working hours are common ones of our society. The reason that I think, but that is more or less negative about Snow. Let me speak positively about why I think that there is not two cultures, but why there is one. I think there are still things that divide us in some ways. But these are due to intellectual laziness, to the barriers of jargon with which any field surrounds itself, not only science, and also to the pressures of time that prevent us from bettering ourselves. But they operate just as much on someone in electrical engineering or chemistry with respect to those two fields as they operate with respect to something in the humanities. So what I'd like to do, in fact, in a positive mode, is I'd like to illustrate the common approaches to understanding and communication that I see in three fields that happen to matter a lot to me personally. And these are chemistry and poetry and the visual arts. And because my proclivities are to go from the specific to the general rather than the other way around, I'm going to do this by showing you three little case studies of stories, essentially, in each of these fields. And I could tell you ahead of time what it is that I see that is in common in these fields, but I'm not going to do it this way. I'm going to instead tell you the three stories, and you can look, if you like, for what you see in common with them, and I'll tell you at the end what it is that I see in them. So let me begin right away with my first story, which comes from chemistry. And it starts, the chronology is important in this story, and comes from my own work. One day, I went into our library. We have a separate chemistry physics library at Cornell, and I go in there every Saturday to see the 100 or so new journals that come in. And I was reading a German journal. This was in October of '73, and the journal was published in July '73. And as I was reading that journal, I noticed an article by a group of German chemists in Mülheim about the synthesis of a new molecule which they called tris-ethylene nickel. I read that paper, and let me show you that molecule. Let's see, now we have to turn on the slides. Let's see if they're... No. They're on. I can't see, so I'm going to have to take the microphone with me just a moment. Okay, here is what is tris-ethylene nickel that this German group made. Ethylene is the molecule that you see at left here. It's C2H4, all 6 atoms in a plane. It's a very important molecule. About 3/4 of all plastics and synthetic fibers are derived in one way or another from this particular molecule. It has the formula C2H4, and what they had made was a molecule where 3 such ethylenes got attached to a nickel. Now, the very first question after a chemist makes a molecule that he or she has is, what is its structure? Now, structure means not only that there are certain atoms in it, nickel and carbon, hydrogen, and not only that they are arranged even, that they are connected to each other in a certain way, the carbon to another carbon and to a hydrogen, but really the structure in a sense of an architectonic structure in 3 dimensions. What is the 3-dimensional shape of a molecule? The shape matters. Every chemical, physical, biological property of the molecule is ultimately determined by its shape. So everyone wants to know the shape. If the molecules cooperate by crystallizing in tiny little crystals, and if you have a machine costing 150 kilobucks, and with 1 man or woman week of work, you can determine the arrangement of atoms in a molecule. The molecules didn't cooperate this time. They didn't form shiny little crystals. They formed oil, and they couldn't figure out the structure. Now, what could the structure be? The structure could be, as you see it at left in this drawing, with the 3 ethylenes sort of lying down around the nickel atom. This is a poor attempt at some representation of this molecule. There's something else interesting going on which I don't have time to talk about, and that is that shape is important. The representation of shape is important in 2-dimensional media. But the interesting thing about chemists is that they're not talented at representing shapes. That is, chemists are not selected to be chemists, nor do they select themselves on the basis of their ability to draw molecules. So what happens is what you have is a bunch of people who are asked to do something which they're not talented at doing. This is one definition of life. And so they invent a code for doing that. A code of representing it by which they can reconstruct these figures which they learn in an organic chemistry course, what they mean, into a 3-dimensional structure. Anyway, one structure is the one at left, them lying down, and the one at right with the 3 ethylenes poorly represented as standing up as soldiers. At least you can see the difference here between those 2 representations. Now, they didn't know which structure it was. They reported the molecule. I saw it in the library, and I said, hey, we are theoreticians. We can do calculations, try to get explanations. And I turned coincidentally to a German postdoctoral associate of mine who was over for a year, Notker Rösch, and I asked him, can we figure out which of these structures it has? And Notker went to the computer, and after a while we could figure out that in fact the ethylenes wanted to lie down the way that you see them on the left side of this slide. Now, we figured that out in the winter of 73 to 74, and we wrote a paper about it in April 74 that we sent to a journal in the United States. And then the very first thing that I do when I write a paper about my research is I make 50 copies of it. And then I send it out to people. These are called preprints. Reprints is what they'd be called after they get published, but I do it before they're published. And I enter a great informal communication network by which we talk to each other about what we've done. Who do I send it to? I send it, of course, to the people who made the molecule, the German group that made it. It would be natural that I'd let them know that I'm doing something inspired by them. But I also send it to friends and neighbors, so to speak, as part of a correspondence. If someone writes me a letter that's interesting, then I answer it, and even if this has nothing to do with this letter, I would enclose one of my preprints as a way of saying, hey, here is what I've done lately. And if the letter's uninteresting, I don't enclose it. So this is what I did. And one day there came such a letter from England, from a group in Bristol. And Michael Green, a chemist there, wrote to me something. I sent him my paper, which said that the molecule should be lying down. And by return mail, Michael Green answered, we have made the molecule tris-ethylene platinum, and it forms nice crystals. It was a one-sentence letter, and he didn't need to say anything more. The reason for this is the following. If this were a good chemistry tent instead of just another tent, what we'd see up somewhere there is the icon of chemistry, which is Mendeleev's periodic table of the elements. And if you were to see that, you would see that, which groups the elements according to similarities in their properties. You'd see under nickel, which is what this, you'd see palladium and platinum. And what that means, they're not equally expensive. Palladium and platinum are much more expensive than nickel, but they have similar chemical properties. So that Michael Green knew, and I knew that he knew, and he knew that I knew that he knew, that anything that was probably true of nickel was true also of platinum and palladium. And therefore, he didn't need to say any more. A week later, there comes another letter that we've solved the structure, and eventually in a paper that they published on this, this is very hard to see because the reprint of the paper, over on the left side is a picture of the rather fat ball of the nickel atom, and around it the bars of the carbon-carbon bonds of the ethylene. You can see they're lying down around it rather than standing up. And I received that information in July 1974, months and months, almost a year before, months before my paper was published on the subject, a year or a half before the English group published on it. So let me summarize the story. Here's a bunch of people in Germany who make a molecule for reasons that are, I don't know. They publish in the open literature. Someone in Ithaca, New York sees this and does some calculations on this. Before even those are published in the open literature, someone in Bristol, England has been in turn motivated by those calculations to do a experimental study, which in this case confirms the results of the theoretical calculations. I wish I could say that every piece of science that I did had as nice an outcome as this one. They don't. But about 70% of them do, and that's enough to keep me going. There is most often, the rest of the time, some predictions that we make are wrong, plain, simple, wrong. And we have to keep living through such situations and go on to the next study. Well, that's my little scientific story. Now, the next story from poetry involves 3 poems, which I will read to you. The first one is by Rainer Maria Rilke, the great German poet, though he was born in Prague. And it's called Archaic Torso of Apollo. The translation, it's in German at the left, and the translation at right is by Robert Bly, distinguished American poet. And I will read it in German, I guess, with apologies to native German speakers in the audience who can listen to my German and in it detect the traces of Yiddish, Swedish, and Swiss German, which for assorted geopolitical reasons have come into my version of German. Let me tell you first the setting, though, a little bit. Rilke is now in the first decade of this century in Paris. He works for a while as the secretary to Rodin, and then is on his own, and he doesn't have any money, and he's down and out, and he's writing poetry. Incidentally, if you want an antidote to romantic pictures, usually written by Americans, of how nice Paris was in the 20s, for instance, I'm thinking of Henry Miller and Hemingway, then a good antidote is Rilke's only novel, which is called The Notebooks of Malte Laurits Brigge, about that same setting, but you'll get a rather different picture of what it was like to live there. This is a poem about a statue, piece of statuary, a typical Greek classical statue or a Roman copy thereof, one which has lost through the vagaries of time all the limbs, the genitals, and you just have the torso. And he's writing about that. Archaischer Torso Apollos. Wir kannten nicht sein unerhörtes Haupt, darin die Augenäpfel reiften, aber sein Torso glüht noch wie ein Kandelaber, in dem sein Schauen nur zurückgeschraubt sich hält und glänzt. Sonst könnte nicht der Buch der Brust dich blenden, und im leisen Drehen der Lenden könnte nicht ein Lächeln gehen zu jener Mitte, die die Zeugung trug. Sonst stünde dieses Stein entstellt und kurz unter den Schultern durchsuchtigen Sturz und flimmerte nicht so wie Raubtierfelle und breche nicht aus allen seinen Rändern aus, wie ein Stern. Und da ist keine Stelle, die dich nicht sieht. Du musst dein Leben ändern. We see the portrayal of the statue by Rilke. He makes us see it. And we see perhaps something a little bit deeper that he makes us aware of, and that is that perhaps the statue, by virtue of being mutilated and by virtue of us having to reconstruct the ideality of what is missing from it, takes on a power over us that is stronger and greater. We don't know exactly why Rilke has to change his life, but it communicates to us the impact of the statue on him. Here's a second poem. There was a Germany, Ithaca, Bristol, England axis in the science. There's going to be one in the poems as well. This is Charles Tomlinson, who is a leading English poet, though he was first recognized in the United States. And this is a poem that he's written about another work of art, and that we are most familiar with, and that would be a typical late Van Gogh at Arles, for instance, in his last 2 years. And you know the kind of work that Van Gogh painted. It's where, with a few brushstrokes heavy, he could endow an inanimate object, a cypress tree, a haystack, a house, or a face of a mailman with incredible power. How does one deal with the problem of the tension that Van Gogh's paintings generate? Well, I know how we deal with it. We go into a museum, we get our high, and then we come out to the real world. Van Gogh couldn't deal with it in various ways, but there are other ways, and this poem is addressed to that. Farewell to Van Gogh. The quiet deepens, you will not persuade one leaf of the accomplished, steady, darkening chestnut tower to displace itself with more violence than the air supplies. When gathering dusk, the pond brims evenly, and we must be content with stillness. Unhastening, daylight withdraws from us its shapes into their central calm. Stone by stone your rhetoric is dispersed until the earth becomes once more the earth, the leaves a sharp partition against cooling blue. Farewell, and for your instructive frenzy, gratitude. The world does not end tonight, and the fruit that we shall pick tomorrow await us weighing the unstripped bough. You may not like the optimistic conclusion in the last stanza, but the basic idea of this poem, the solution, or that there are no solutions in poetry to the problems that poetry poses, the resolution that Tomlinson comes to draws back upon our knowledge of nature and what happens to tension and to colors as dusk approaches, and that is that they resolve themselves in one way or another. The solution is in nature itself. Poetry cannot only deal with paintings. It can deal with so much more in the realm of nature and emotions. And most importantly, it can deal with science, though that's another story why science and poetry parted somewhat. But I want to read you a poem by a colleague of mine, and in fact one of America's greatest poets, and that's Archie Ammons. And it's a poem about a vortex, about a spiral. It's called Spiral Rag. And so it's about a scientific subject. Now read it and then make some comments about it. Opposites attracting, could easing jar to a standstill, or unmoderated blast into mutual annihilations, or just at the meeting node veer around each other, the momentum transforming into spin, which would of course generate a whirlpool flow through, so that the energies undemolished and still current could find a place where slowed they could give up their terrible shapes and tendencies and dissipate into the continuum from which they might eventually return. Anyway, the circle won't do except as an infinitely extensible outer boundary. Also the sphere won't do for some reason I've forgotten. No transfusing discharge, just surface extension with only surface flow. But the vortex will come close to doing, because it gives a standing motion shape at the central interior, so that the high formations finding each other's have a way to go. The truest motions, truest shapes, the spirals inward arc, the inward turning whirl that promotes a direction for the meeting that can wear down or fly apart somewhere past the tightening screws whirl. Whatever, what a mechanism for averting, for taking in, changing and giving out, for holding still while the motion flies. The mind figures, but even though it wants to do well, never comes up with the source of what it comes up with. Now, let's talk a little about that poem, this last one. First of all, the poem to me is as good a description of that vortex whirlpool as a lot of partial differential equations I know. And in particular, what's interesting about it is it makes the point that it's not just a spiral, but like black holes, vortex is a mass transport device for moving something along. In fact, the poem moves along at various speeds, and that's one of the interesting things about it. But let me bring your attention to a number of things in this poem. The first inclination that some people have about this poem is it's just the writing down, sort of prosy, of some impressions about this vortex, right impressions or not. But really it's much more complicated than that, because what he's doing is, through the structure of the language, and it's certainly not rhyme, but through the structure of the language, and it's not even meter, he's making me read, or us read, faster or slow at a certain time. And he's doing this by a number of unusual devices. Let me point to two. One of the things that you'll learn in a poetry workshop probably not to do when you're writing a poem, and what he violates, is to put an article, a the or an a, at the end of a line. And he does it even at the end of a stanza, not only at the end of a line, throughout this poem. Why are we told not to put a the at the end of a line? Well, because an article belongs with its noun, and when you are doing the separation, you are creating an artificial separation. Now, he doesn't do it just for fun. He uses that to, of course, to slow me down. When he, at the end of the second stanza, has a find a, and that slows me down. When an a comes at the end of a line, and then at the end of a stanza too, that really slows me down. And I try to read it to slow down, not too much, but visually it slows me down. Then he's got the slowed in the next line, the first line of the third stanza, the place where slowed, he's got that slowed surrounded by two commas. That slows you down an awful lot. So what's happening here is the form is fitting the function. That's part of his technique. The other thing, if you skip down to 1, 2, 3, 4, 5, the sixth stanza, finding each other, have a way to go, the truest motions. Okay, when you see a possessive case, apostrophe S in English, I get very curious about what is being possessed by the thing, by the truest shape. So I go on to the next word quickly in order to find out what is being possessed. And so I find truest shapes. He withholds the object that's being possessed from me. And he goes on, the spiral's inward arc. What he's doing here is, through the withholding of this possessive term, of the possessive case, he's making me read that faster in my mind, which is the main way that a human being interacts with, not by having someone read it to you, but on a page. He's making me read it faster. He's walking what I would call the tight edge of syntax, and that's what Ammons is in fact very good at doing. That's the end of my poetry story, those 3 poems. And you might think about what the heck does that have to do with the science that comes before. Let me tell my art story here. And we are in a singly, thanks to the cooperation of Indiana weather, I was praying for a thunderstorm at least, so we could have some darkness here. But you're going to have to suffer with seeing these slides with too much light here. Now let's talk about portraits. And here is a sequence of 3 portraits, of several portraits. This one is a portrait of Federico di Montefeltro by Piero della Francesca, and it hangs in the Uffizi in Florence. It's a fairly realistic portrait of the Renaissance. If we could see it in detail, you would see that the man is portrayed with warts and everything. And then there is a landscape in the background. A portrait like this could not have been painted 200 years before this one was painted. Representations then were just iconic. Here, this is a more realistic representation of this man. Here, a little bit to the north, though the portrait that happens to be hanging in Spain at the Prado now, is a portrait of a man by Dürer, a very serious, realistic, dour man. Now let's reflect a little on these 2 reasonably realistic portraits. Portraits, of course, seem, on the first inclinations to say a portrait is just a representation of somebody. It's just something you hire somebody to do. But portraits are much more complicated than that. Portraits are a very complicated transaction between at least 3 people with millions of others looking over the shoulder of the 3. The 3 people are the sitter, the painter, and the viewer. And the others looking over the shoulder are all the people who've gone in between and who have informed the minds of the various people involved. Let's examine the interests of these. The sitter has paid some money to have a portrait painted. He expects some representation, but the representation that he expects would be different for different purposes. What this man, with whom I wouldn't like to meet up at a business transaction, what he chooses to put in the boardroom of his bank in Florence, in Siena as it happens to be, what he chose to put up there would not be the same thing that he chose to give to his children, or maybe it is the same thing, in which case it tells me something about him. But there are different things that you choose for different purposes. And he wants that representation to be reasonably realistic. He wants his power to be seen as it is in this painting, but perhaps he wants some positive side of his catered to. And then there's the painter, much more of a craftsman than an artist, in quotation marks, at the time that these were painted, paid to do representation, knowing that he cannot stray too far. There's no way he could do a Picasso-type sketch at that time of what this person would be like. But yet the painter also pretends to some depth, and on a basis of a few hours, a few days of a sitting, would produce a representation that perhaps captures some inner part of that person. What right does he or she have to do that? on the basis of such little knowledge. And then we come 5 centuries later with the baggage of the ideas that we have about what constitutes a realistic representation or not, about what makes a man serious or not, and we interpreted this in a certain way. It's a very complicated transaction. Paintings evolved apace, this in different ways. This is a portrait by Rembrandt of Saskia, of his wife, and the quality which we see in Rembrandt is, whereas the light in the previous representations was external and frontal, or even if it was from the side, the quality of light that emanates from this portrait seems to have, through the artistry, seems to come from the inside of the person herself in this case. Here is something which is terribly difficult to see. But I wish I could show it to you. All I can tell you is if you get within 1,000 miles of Madrid, you should go there because it's been cleaned recently. And this is this is what has been called by a literary critic the greatest representation of representation ever painted. This is Las Meninas by Velázquez. And what it is there's a gigantic cavernous room created whose depth is emphasized by that courtier who is in the back, visible through a door, a space of light at the back. And that room is framed with recognizable paintings by Rubens in there, so that you can identify paintings which were in a Spanish court. And then on the left side, in front of a gigantic canvas, this painting is 12 feet high, is standing Velázquez, and he is painting looking out our way. Velázquez, obsessed with becoming a member of the aristocracy, obsessed with making the transition from craftsman to artist. 18 years, all his life, he tried to join an order of nobility, the Order of Santiago, and he did that eventually. In 18 years after this painting was painted, he goes back and paints on his insignia of the Order of Santiago on his uniform, as if he finally got into the fraternity that he wanted to get into. And there's Velázquez painting. At the center is the Infanta Margarita, who is the subject of this title, surrounded by the 2 ladies in waiting that give the painting its title, Las Meninas. And there's an iconic dwarf, a dog. And then why are these people all looking our way? Because presumably their Catholic Majesties, the King and Queen, have just come into this room and in the process of the portrait of the Infanta being painted, and they have all turned that way. And we can see the reflections of the King and Queen in a little mirror in there. Now you can see why this is called representation of representations, because it's absolutely incredible what's going on in here. This is a painting within which there are paintings, within which another painting is being painted, in which people are looking out toward us and looking back in and are seeing their reflections. But I could go on for an hour about this painting, but I won't. What I want to do is to focus on an absolutely trivial point, and that is what we make of a face or a figure depends on how closely we look at it. The Infanta Margarita here is a rather stiff little girl, I think. The reason, that's my first impression, the reason for that is that something has changed with the centuries about what we consider to be proper dress for women. And the kind of corseted little gown that she is wearing, we do not think is something that a free little girl would wear. Now, if we defocus from that, but that happened to be normal dress in those circles of society in which she moved. If we defocus from the dress on the face of Margarita, and here's a series of close-ups of her. Here's one, here is another, and the next one is as close as I dare to get, and if we were to see this, you would see that we begin to see the brushstrokes in this one. But if you look at her face, there is, to me, very little emotional distance between this face and a face of a little girl painted by the master painter of women's faces of the 19th century, and that's Renoir. This is a Renoir girl hiding in a Velázquez portrait. And that just matters how closely you look at it or in what aspect you look at it. This you cannot see, but the next 3 slides make the point. Sometimes people think that the difference between art and science is that there are no footnotes or references. There is no sense of time or history in art, whereas in science there are lots of footnotes on any paper, and we stand on the shoulders of giants, and we do follow on the work of others. Well, artists can do in the same way. Pablo Picasso, late in life, went back to a series of black and white portraits, rather paintings based on various historical paintings, including one of Velázquez, Las Meninas. We can't quite see it. Maybe some of you can see that this is related. You can see the shape of Margarita. And this being Picasso, of course, the figure which looms largest in this is that of the painter, Velázquez. Here is Peter Waite, a contemporary English artist. This is called Lenin Las Meninas. The room has been emptied of all figures. It's still recognizably the room of Las Meninas, and there is an iconic statue of Lenin, one of millions that you could see in the Soviet Union up to 5 years ago. And his head is right where the head of the king and queen were in the other painting. And here is Joel Peter Whitkins, and it's just as well that you can't see this because you would get in trouble with Senator Helms and others. Anyway, that's something that's clearly modeled after this is a visual footnote to Las Meninas. That's what these are. Let us shift civilizations and reference for just a moment. Oh, well, there are two other portraits I'll skip a little later on by Munch and Ernst Ludwig Kirchner. I wanted to show you finally, skipping a little bit civilizations, I wanted to tell you something about some ceramics. And these are in fact not just any ceramics, but they're Japanese ceramics. In Japan, ceramics is not a craft, it's a high art form, and it has been that way. And ceramics, of course, has been a constant of civilization. Wherever there have been human beings, you find pieces of pots. It's as simple as that. But particularly in Japan, China, and Korea, and Japan especially, ceramics reached a high point of development. In part in Japan, this is due to Chinese and Korean traditions. In part, it is due to a background of native and religious and philosophies and statements, and it's reached its highest point in its culmination in the development of a philosophical framework around the tea ceremony. And I was glad to see that there was, in fact, as part of this celebration, there was a tea house, I understand, built by some architecture students, and that someone performed the tea ceremony in it, I think, over the weekend. Any object in Japanese culture that is associated with a tea ceremony acquires a depth of sophistication which is greater than it would normally have, and that happens especially with ceramic objects. This is a bowl by Koetsu. This is sometime at the end of the 16th century. It's called the Momoyama period. And the color just escapes. It's a very subtle here, mauve that shades through a band to white. And this object just begs to be picked up. It's a rather small object. Here are two other views, equally inscrutable. It's a small object, about 4.5 inches across, and it just begs to be picked up. And one of the great things about being in Japanese homes is that you are asked often to handle objects such as ceramics, which are very old, as part of doing honor to the guest. It begs to be picked up and rotated, because only in being rotated do you see that the particular approach, the particular imperfection, this is roughness and smoothness is one element. Another is the approach to circularity that occurs in this. This other bowl is by Ogata Korin, who is, and it's made a few years later, just for calibration. The Velázquez painting was painted in a different part of the world in between the time that these two bowls were thrown in Japan, which was rather interesting. This Ogata Kenzan was the brother of Ogata Korin, a famous painter of screens. You can see a lot of the screens in the Boston Museum of Fine Arts. What this one has, in addition to the play with roughness and smoothness, it has a decorative element, whereas the previous slide previous bowl could conceivably be mistaken for a Chinese object. This one cannot. This one is uniquely Japanese. The Japanese tradition of making ceramics has persisted to this day. There are a number of other ceramics that I would show you in detail here. This is one that's at the Cornell Museum by a resist technique, a figure of cranes flying against a background. But in fact, I will stop with these that I have, and let me say a few words about them. What I wanted to say about the ceramics, just in conclusion, is that what is remarkable about Japan is not that they can make better cars than we can. What's remarkable is that they can do that while maintaining a tradition and respect for traditional objects such as the ceramics that accompany the tea ceremony. And you can see that for yourself. If you go to Japan, go to a department store. It happens department stores is where art is often dealt with. And you'll see a floor in every department store, no matter how modern, dedicated to traditional object of one kind or another. Well, now I come really to the end of my three stories. The last one had two parts on portraits and ceramics. And what I want to now talk to you about is what it is that unites, as I see it, just my perspective, these seemingly disparate objects of human creation. The chemistry of that trisethylene nickel, my work on it, the poems of Rilke, Tomlinson, and Ammons, the bowl of Koetsu and Kenzan here, or the series of portraits from the Renaissance that I showed to you. Well, first, perhaps trivial, but all important, is that these are objects of human creation. They are man or woman made, synthetic, and unnatural. And I want to say it that way because very often scientists think that they are being typed by society, and sometimes they are, especially chemists, as the producers of the unnatural. Mind you, if you want to call what the work of man is also natural, that's fine, but then you just do away with the problem, and then there's nothing to talk about. But I will separate the work of human beings from the work of nature in general, and in that sense, these objects are as unnatural as you can get, as is the 14th Amendment to the Constitution of the United States, or as is the chemicals that we make. Being synthetic or unnatural is nothing wrong inherently. It's what use it's being put to that's bad. But anyway, these are objects of human creation. Now, in some sense, that's trivial. God knows we've been put on this earth to create at least too much of ourselves. But in another aspect, it's not so trivial because a lot of the element of surprise or of novelty that is a human reaction to good science and to good art, or to a reading of a poem, a lot of that feeling comes from these things being created and constructed by another human being. The second thing that I see is that the creative act is accomplished with craftsmanship, with fine attention to detail. The scientist's concentration on minutiae, on the measurable and reproducible, that often leads to a stereotyped image of a dry or insensitive personality. But how far that is from the motivation of a good scientist when seeking for the essence of the matter. His or her craftsmanship, for that is what attention to detail is really about, is not very different from the craftsmanship, the care and choice exercised by the poet in the choice of a word or a metaphor. The Japanese potter's studied introduction of imperfection, the seemingly haphazard passage from rough, unglazed area to smooth glaze, that's hardly an accident. Many, many pots were reduced to shards before that planned irregularity was allowed to reach our hands. Perhaps another way of saying this is that this thing about craftsmanship is to say how easy it is, in fact, to tell good science from bad science and good art from bad art, and craftsmanship has a lot to do with it. Sure, you can fool some of the people some of the time, etc., but in the end, if you start looking for craftsmanship, you are in an awfully good starting point in looking for at anything. The third thing, the sciences and artists' exploration of the universe, I think, is most highly valued when it is accompanied by conciseness, by an economy of statement. The power of a mathematical proof, of an all-encompassing equation, the irrefutability of a symmetry argument. These are the things that make scientists hold their breath in awe, and how they wish they could communicate to others the conciseness and generality of a physical phenomenon that's well described by a mathematical equation. Operating in a more complex realm of emotions and philosophy, the statement that's made about the complementarity of imperfection and perfection by these Japanese bowls, or about the possibility of a transition from Van Gogh's madness and the natural world that's made in Tomlinson's poem, these to me are equally economic solutions, or as I said, resolutions of problems that concern man. If one possible definition of good art is that it is an abstraction from the reality of nature or our emotions, of the essence of things or feelings, how different is that really from good science, which is the concise statement of the laws of nature? So, creation with craftsmanship, with an economy of statement. The next thing that I see in these things is that the art of communication, I think, is explicit in the activities of both scientists and poets. The openness of the chemical literature made that German Ithaca Bristol axis conjunction possible. Our journals in science are a portable window on a world, one that opens just as much in Novosibirsk and Dar es Salaam as it does in Ithaca or in Bristol or in Germany. It's a window through which the richness of nature flows and there is transformed into the beautiful landscape of the mind. Now, I have picked some poems that talk about the painting. I've talked about others. Things must communicate. We reach out to an audience, and we come there to a little bit of a problem. I think we do reach out to an audience. That Japanese bowl begs to be picked up, and I've already alluded to the very complicated interaction of sitter, artist, and viewer that occurs when you look at a portrait. Now, some poets will tell you, no, communication is not important. I'm just writing for the drawer. Now, my general reaction to that is I don't believe it. First of all, I don't believe it unless they're in a totalitarian country where they get into trouble for writing. In general, I find that this is an affectation, that in their mind, maybe they're writing for themselves, but if they're writing for themselves, then it's a therapy and not poetry. And I think my general experience is that poets usually have an audience in their mind or a real audience outside to whom they are speaking. And my general experience is those reluctant poets who claim that they are not writing for the drawer and they don't care whether anyone publishes their material or not. For that very special you, if you just scratch them a little, they'll read you everything that they've got. It's just in the nature of the act. The communication of science or art, I would claim, is an international and cross-cultural act. It's an affirmation of the unity of humanity in the face of a myriad divisive factors. Now, the international aspect of the science was clear. Now, what about the other things, the poems and the visual arts? Can you translate a poem? That's why I put in a poem that was translated in there. And one attitude is to translate is to betray. That sounds better in French. Those of you who know that would see it as a wordplay in French. Every translation, at best, if it succeeds of a poem, at best is just another poem. It's not a translation of the poem. Whereas in science, translation or paraphrase is a natural thing, and it's hard to imagine a translation of one of these objects of art. I would say this, that surely the particular cultural or semantic setting matters. It matters, and it's important, and it may cause a barrier. Perhaps, but there's another way of viewing it. Perhaps you need to learn about the tea ceremony to appreciate the Japanese bowl. Perhaps to really read the Rilke poem, you have to learn German. But the learning of that process is itself a culturally enriching act for you as the viewer, reader, the consumer of this information. And there is no more uplifting act than actually the act of translation, the act of wrestling with words in another language. So I would say that these are intercultural acts as well as communicative acts. I think also connected to the act of communication, which is inherent to art and science, and to their international presentation, I think is the altruistic nature of the achievement. We create and we rejoice in what we create ourselves, but I think that part of the pleasure is that we have something that we can be shared with others. How else are we to explain the rush to share with others what we have discovered? Now, publishing, telling, showing, selling, those are all acts which are very rich in psychological complexity. In them are elements of wanting to show others how good we have been, seeking praise, claiming power, appeasing deceased parents. All kinds of dreadful things are going on in front of you when somebody is speaking to you. But I think I'm not the only one to think that there is more to human beings than self-interest, and that the desire to share newfound beauty and understanding is deep, deep within us. Which brings me to beauty and the search for aesthetic pleasure. The beauty is obvious in these arts. It's in the art. It's up front, though rather interestingly, it's only in this century that we have learned to call art not only that which pleases us in some way, but also that which occasionally shocks us and makes us question our existence. Aesthetic principles rank very high in the minds of scientists, even as the ritual medium in which scientists are forced to communicate. The scientific article precludes expressions of emotion. Words like beautiful, neat, elegant abound in the verbal discourse of scientists, but they themselves have dug a hole for themselves by forbidding themselves to express such emotions in print. What's interesting is, in fact, to trace the elements of a common aesthetic. And let me mention some to you. Symmetry and asymmetry, which was mentioned in the introduction, are such. Symmetry sets order and repose. Asymmetry is what perturbs us and sets emotion. Actually, is much more interesting. Asymmetry playing off versus symmetry. The simple and the complex are elements of an aesthetic. A Greek classical temple is beautiful, and so is a molecule that is shaped like a cube or like pressed tension of a Van Gogh painting, and that human frenzy would pass. And Rilke understood the life-enhancing essence, the perfection strengthened by its being made of a statue that was mutilated, in fact. My life has been transformed. I'll tell you how my life has been changed by reading that Rilke poem. I will not see a Greek classical statue again without thinking of Rilke's poem. There is no way I can get his poem out of my mind. That's not what he meant in his poem, but that's the transformation that it's worked for me. Nor will I ever see again, when I look at a chemical journal, when I see an ethylene near a nickel atom, nor can I ever possibly forget how that German compound, nor the way that I explained the way that they shape around themselves. Before I ever call an object imperfect or rough, as I'm often wont to do when I see something on first sight, I will think of that Japanese bowl and how I was wrong to call that just something that was thrown together. My life has been changed in these various ways, and in thinking about how our lives have been transformed by art or by science, I don't think science comes off that particularly well. I think in the spiritual things that matter to us, the transforming capability of poetry and of the visual arts is immensely more powerful than that of science. I think there is only one culture, what unites us is that we seek to understand the world around us. It's not surprising that the search for understanding takes on many shapes, many forms, and certainly not astonishing, as we often see that we, being human, we should think that our degree of understanding, our nature of understanding that we achieve is superior to that of others. But that is just a weakness. God knows that this century and that we are living in and every day of our life lends us evidence of these faults of ours. But there is a time to praise. And now I'm actually paraphrasing another poem by Rainer Maria Rilke. There is a time to praise the achievements of the human mind and hands for creation with craftsmanship, with a certain intensity, an economy of statement, concisely communicated in a way that cuts across cultures and tries to serve others, with a feeling for beauty and always, always trying to understand. That is the one culture that we have to preserve. Thanks.